Good day to you, wherever it is, morning, noon, or night. We are going to have a little bit of fun with some JavaFX today and do a little demo. Now, this one I'm actually going to solve, so yes, you can use it. Yes, 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 and yes! If you're watching this, you can use it as one of your assignments. Now, I think what we're going to do is we're going to do this one right here. This one looks a little fun. Rectangle filled with a random color. So we're going to get into that a little bit. But first, I'm kind of curious about a few things that I want to ask Sandra about, to see kind of where I'm at on it. Oh, no, not that. Here we go. Hey, Sandra. I'm with my students again. How are you?
Hey there, I'm doing well, and hello to your students too.
Yeah,
Let's dive right.
Do you have a good Java joke?
Absolutely. Here's a classic one for you. Why do Java developers wear glasses? Because they don't see sharp.
That one is pretty good. That's not bad.
Glad you liked it. If you need more jokes or anything else to keep the class entertained, just let me know.
No, I had a question that I wanted to talk about and see what your thoughts were. How and why or where did object-oriented programming begin?
The origins of object-oriented programming, definitely a cool little history chat. So it really started taking shape in the 1960s. The language that kicked things off was Semula, which was developed in Norway. People were trying to simulate real-world systems, and they came up with this idea of objects to represent things. Later on, languages like Smalltalk in the 1970s really popularized the whole OOP concept. So it all began as a way to make code more like the real world, treating pieces of data as objects that you could interact with.
Oh,
and the rest is history.
Yeah, so I was giving my students a, metaphor or simile. I can't even tell the difference between those two. I was using the watch as an example of a real world object that we model data and that can act upon itself.
Yeah, that's a great analogy. Using a watch is a perfect way to explain it. It's basically like saying, here's this object in the real world, and just like a watch has parts and can do things like tell time, in programming, we create objects that have their own data and their own behaviors. It's a pretty neat way to make that whole OOP concept click.
I love how you slyly corrected me on my metaphor analogy problem. That was great. Good job, Sandra.
Absolutely glad that helped out.
Oh, hey, I'm sorry, I gotta run. We gotta get going. It was nice talking to you. Thanks for the info. All right, bye. So a little bit more on that. Some data, whatever. And a horrible joke. Let's get going on building what I was talking about. And what we'll do is we will open up that IDE that I showed you to create, and that we called the Maven project over here that we set up in NetBeans. So let's open up that baby, and then what we're gonna do is we're gonna play with the Java canvas. Now, a canvas is 2D drawing. Every programming language has some kind of canvas, and they all work the same. So if you know how to do the Java canvas, you're gonna know how to do the JavaScript canvas. There's gonna be a little bit different types of code. You're gonna be able to do the C# canvas because hey. Maybe you want to C#. I don't know. Do you? I don't even know if Sharp is out there that I could look at. All right, Maven project. And then what we need is that canvas. And the canvas is going to be our 2D drawing area within a graphical window. And again, that's every language has the ability to add a canvas. And it's sort of form-based. The technology itself. So let's get this loaded up. Looks like it's running. Let's get our code showing. Okay, so everything's pretty much happening here. And what we're going to do is we need to create a canvas and throw it onto the scene, and then show that canvas on the scene. So let's do a little bit of some research so I'm not writing JavaScript canvas code. And let's just look into Java Canvas and get some idea of the syntax and semantics. Okay, for our research, we're going to use the terms canvas in Java. Let's go look at Java Canvas examples. We should just say Java Canvas examples, or example. Probably the AI will give us an example. Okay, here we go. The add function. They're using an add function. What are we doing here? They're using inheritance for this. I don't like that. We might have. I don't. Let's look at some other. Let's look at. Here we go. This might. Yeah. This is much. Yeah. This is much better. So we're not inheriting from the canvas object and creating our own canvas. We're just going to use one. Is that another? Let's see. Some more examples that we can find. Oh, you know what? Let's do this one a little bit better. Let's say draw a rectangle. Oh, they're treating the actual thing. That's interesting. Nope. Bad example. We're going to probably just go to your book. Yep. Your book does have a good example, and it's actually simpler because we're gonna treat the window as the canvas. So let's go ahead, and it appears that as long as we are in this function, and we create the rectangle with positioning or an ellipse, we're going to add it at some point to be drawn. And right there, this group right there, that's where we add it to the canvas, or to the window to be drawn, which is the scene. Okay. So we instantiate the shapes first, then we assign values to what's inside of the shape as far as the fill color. So this is a nice way of doing it. It's totally object oriented. A lot of ways with an ellipse, you would call a function and that contains some kind of arc argument. This is a very nice way of doing things. Let's go ahead and do this rectangle. Okay. And we got our code. Now, how do we translate that? Well, let's just create it first. Let's get the code in there. Oh, that's not the code. Copy. Looks like my copy paste don't like me today. Sometimes you have to get beyond their crap and do a Control C and a Control V. No, they're really good. Dang. Let's see if it works this time. Oh, they are good. Okay. We do it the hard way then. Fine. Let's see. Let me get this on, and let's just do it the old school way. Type it in. What we are missing from the library is this one right here, shape. So we need to add that. So it's going to be import JavaFX, and then IntelliSense will get us there. It's in scene. So we're going to do import JavaFX dot scene. Excuse me, Mr. Horrible Keyboard. Scene dot shape. Okay. And we're going to go with all shapes to import. Make sure I'm getting our syntax right. So that's a star at the end, meaning I want all of them. So you see how it popped up with those little, arc, whatever. So we say, no, I want all of those imported, and put a star there. And then, let's see. We should be able to clean and rebuild with no errors. Okay, one error. Something's wrong. Ooh, it does not like me. Okay, let's be very explicit then. I might be missing a space in the syntax and semantics of it, but we got our rectangle. So now we can create a rectangle, and we can say, hey, I want a variable of the rectangle data type. So we're going to say, hey, I want a rectangle called myRectangle, and it's going to be equal to a new myRectangle. Now, the way that the X and Y coordinates work in JavaFX is that it all comes from game programming, starting with text. So everything's left to right, top down. And the coordinate system, horrible box, excuse me, X, and Y start at 0, 0. So as X increases, you go this way. As Y increases, you go this way. So if Y decreases, if you have something on the screen that you're drawing here and you want to decrease Y, that means that you want it to go up. If you want to decrease X, that means you want it to go to the left. Increase X and it goes to the right. Increase X and Y and it goes down. Increase X and Y by different proportions in that direction. So it's always 0, 0 up here. And the direction it travels is based on the values that you are using if you are moving something on the screen. In this case, we are going to be just static. So we can start with, let's just do a 100. Let's do a 100 by 100. And so that means start here. And then we're going to do a 50 by 100. So that means either, depending on how it built, that means it's either going to be a box of 50 pixels down that way or a box this way, depending on how the function's built. So let's look at it, give it a shot. We're going to go at location 100, and we want 20 by 100. Oh wait, 100, 100. Location 100, we will need X. That's X, 100. Here's Y, 100. And here's width and height, most likely. It's usually width and height. It's never height and width. Well, okay, I could be right. I'm lying. So let's just find out. We'll call it whatever it is. 20, okay. Now that right there, I messed up. That's the rectangle. Okay, so let's just get that to compile. Okay, I'm going to use my hammer and my brush. That means clean and rebuild. So you don't have any, you're not compiling off of any older supporting code at a lower level. Cool, we're good. Now it appears to draw a rectangle. What do we got? As for examples from our book. Apparently, we just need to set the stroke. Now the stroke is the border of the shape. How many pixels wide it is and its color. So let's go ahead and use our rectangle, and our rectangle is instantiated as my rectangle. So I'm going to say my rectangle dot what did I want to do? What was that at again? Set stroke. Dot set stroke. Okay. Dot set stroke. Okay. And this is where an enumerator is used, called color. It should be. There should be a color enumerator that we need to bring in as a package. And what do we got? We got color, the color enumerator. Do we need to include that? Yep, look at that. So that's an enumerator, and that's exactly where a good enumeration can happen. So let's just do JavaFX scene.paint.color. What was the next one? Was it input? No, it was something else. Paint. For the paint object. There we go. Okay, now we can use the enumerator color and set the color of our stroke. And we can also set the color. You can do it from RGB too, so you can get any of those 16 million colors that you want. Or you can use something that's already enumerated for easy access. Okay, so we're going to set the stroke color, and then we're going to set the brush size. And the brush size, we're going to go with 2 pixels, I believe. Stroke width. Okay. There it is right there. Let's do 5. Okay. That instantiates the rectangle. It gives the instructions on what color to draw, what to draw, and how wide pixels we want to draw, and where to draw it with whatever size. And it's just, it's going to do a line and draw that. We can set a fill too and fill it up if we wish. So let's go look at the next line that we need, because we're going to need to package this into the scene. And it looks like we're setting the fill. I might need to do that. We'll find out. Actually, it looks like we'll find out. Let's see if it works. Right here. We need to add it to the scene. So where is our group to add to the scene? All right. I think what we could do is let's just get rid of this. Well, let's look at what they got. They got a group. We've got a stack paint. Yeah. Tell you what, let's get rid of the label. We don't need it. We don't want it. We probably don't really even need this. Let's see. Let's just, you know what? Let's get the example with the grouping that we're going to add to the scene. Let's get that example and use that. So we're going to say group. What do I need for a group? Right there. Group. All right. So let's get into that code and get our group together. Now we're going to go up here again, and we're going to say import JavaFX dot. Now, where's group located? Example. Let's see. Group is new group. We can just put it, instantiate there, and throw in the shape. And then when we set the scene, we set the size of the scene that will include the shape or the group to draw. Okay. And what are we including? That's why I switched over there in the first place. Come on, answer your question there, buddy. Scene.group. Okay. Yeah, guys, this stuff I don't memorize. I don't suggest that you do either. Get a general understanding of how languages work, because if you're going into software development, you're going to have to get used to working with 4 at a time. And things get a little clashy, especially up in the noggin. The references are beautiful. You have to use them. All right, we got our group. Now, we're going to instantiate our group and then add it to the scene so that our group can be... I'm sure we could just add the rectangle to the scene, but I'm not going to mess around with it. New group. And then the new group, we pass in my rectangle. And then we pass in the group. So we can add some more shapes to that if we want. Let's see if it'll compile. Okay, and let's see if it'll run. There we go. So yeah, width, height, location, X, Y, width, height. And when you set the scene, you're adding it to the canvas. You can, use a canvas though. I will have some supplemental videos where I get a little bit detailed into the canvas. I believe we roll the dice, all kinds of stuff. A lot of fun stuff. But this will get you a good start, and you can use it for your submission this week if you wish. And do more reading on JavaFX. We're going to be playing with that throughout the quarter. Make sure you get that, and then you should be familiar with objects by now. And I know that that's kind of a mind twist, wrapping the noggin around what objects are. So just remember, objects are user-defined data types, but everything is a number. It always comes down to numbers inside of it, which we call primitive data types. Float doubles, ints, which Java treats specially as a primitive data type. Yeah. Hey guys, take care. Bye.